Okay, essay 11. So what we're doing here, so the problem starts, what is the evaluation? Well, now, what evaluation? Well, and kind of the first part of this problem is to figure out what is the appropriate evaluation in the sense of, all the evaluations that we describe in this section. What's the context here, and what does evaluation mean in that sense? So that's kind of the first part of the problem, to figure out what does that evaluation word even mean. And then the second part of the problem is to actually compute it. So here we've got a scalar valued function given, and then we have a two-dimensional region in R2. And if you look in that if you have solid two-dimensional regions in R2, evaluation means double integral. So what the problem is asking is to do a double integral of this function f of xy dA over some region in R2, I'll call D, where D is bounded by these two curves, y equals cosine x and y equals x squared. Right? Does that make sense? So that's what we're going to interpret here. The purpose of saying it in this way, what is the evaluation, is I want to sort of, we're going to be in the business in chapter 6 of, finding whatever context we find ourselves in, there is a natural type of calculation we want to do. And again, as I've said in class, we're integrating differential forms, whatever that means, right? But in the specific context, it means something that's always the same and that we can nail down. And in this context, if you have, I claim that a function of two variables is one interpretation that you can take of a differential two form in R2, whatever that means. Okay. Right. Okay. So now let's actually do the calculation. We're doing a double integral over this domain of, let's see, our function is x cubed dA, and let's see, our region is bounded by y equals x squared and y equals cosine x. So there's this region here. Exactly. And you sort of see where this is going now?
I only saw the positive half for some reason.
Oh, I see. Yeah, no, it keeps going. Yeah, absolutely. So you're computing this double integral. Now let me just point out, and let's see here, how much do I want to give away? Chapter 5, techniques, right? You can compute double integrals. You can, find this intersection point, that intersection point, do an integral dx, integral dy on the inside, bounds or x squared and cosine, and you can do it that way. I think it's going to be pretty rough that way, but you can do it. Or you can be really clever. And let's see, gosh, how much should I give away? How many people are getting the hint of the clever hint that I'm hoping that you'll notice here? Okay, good. All right. So let me just do this. I'm going to draw that little line there and walk away and say, think about what you might do with that line and how this calculation might be a lot easier. And again, I claim this kind of stuff happens all the time, so you definitely want to keep a lookout for this this kind of stuff. Okay. All right. Does anybody need me to expand on this? I will. I'd be happy to expand. I just want to. Everybody good? Okay. All right. Great.